In today's video, we're going to be looking at a new product from Ubiquiti, which is the brand new UniFi Enterprise Fortress Gateway. And this is by far the most powerful gateway device they have ever launched. And I'd also like to say a massive thank you to Ubiquiti for sending me this over to take a look at. So the Enterprise Fortress Gateway is classed as a cloud gateway, much like the Dream Machines. And what that means is this acts as a firewall, but also runs the UniFi controller software. So this device will run the controller, which will also manage all your other UniFi devices. But unlike the Dream Machine, which tries to be an all-in-one console and NVR for small businesses and home users, the Enterprise Fortress Gateway focuses purely on networking and is designed to just be extremely powerful for much larger deployments that just require a lot of raw networking power. So as I mentioned, the Enterprise Fortress Gateway is a UniFi cloud console, meaning that it runs its own UniFi controller to manage itself and your other UniFi devices. However, if instead of this you want to be able to manage it through an external UniFi controller, either cloud hosted or hosted on your own servers, instead of the Enterprise Fortress Gateway, alongside this they're also launching the brand new UXG Enterprise, which essentially is the same thing as this, but instead of running its own UniFi controller, can be managed by an external controller. So you have both options there. Either you can go for this device with its built-in controller, or go for the UXG Enterprise, which is the same thing, but with an external controller. So first up, let's take a look at the hardware. So first up on the front, you can see we have the network interfaces. And on here, we have a pair of 2.5 gig copper ports, a pair of 10 gig SFP plus ports, and then a pair of 25 gig SFP28 ports, making this the first UniFi gateway that has 25 gig Ethernet. Now as you can see by default, the first 2.5 gig port and the first 25 gig port are designated WAN ports, but like other UniFi consoles, these are just kind of the default designations. You can easily completely remap these. So if you wanted to have your two 10 gig ports be WAN ports, you could do that. You want your 2.5 gig ports to be WAN ports, you could do that. Then all the others would be freed up to be LAN ports. You can completely reassign these as you desire. And then apart from those ports, all you have on the front is the inbuilt touchscreen. And straight away, I can already see all the comments coming in from people saying, why have they got rid of the 8-port switch? Why have they got rid of the PoE from the UDM-SE? And what's happened to the hard drive base? Well, the key thing to remember with this is targeting massive, large deployments that need things like 25 gig Ethernet. It's not targeting small businesses or home users. And realistically, if you're putting this in a deployment that's going to have 25 gig Ethernet or at least 10 gig Ethernet and need really high-end IDS and IPS throughput, you're not going to care about having a little 8-port switch, but whether it has PoE or not, you're going to have external switching. Likewise, you're not going to want to dedicate the processing power of your gateway to UniFi Protect or running as an NVR. You're going to have external NVRs. So the idea with this is that unlike the Dream Machines, which are brilliant for all-in-one devices for someone who wants an NVR, little 8-port switch and everything in one unit, this device is focused on networking. So you don't have any of that extra stuff. It's purely an absolute networking powerhouse to act as an extremely powerful 25 gigabit capable firewall. Next up, taking a look at the rear, we can see we have 3 cooling fans to cool the CPU because it's a very powerful CPU, and a pair of redundant hot swap power supplies. So whereas a Dream Machine has a single built-in AC power supply and a separate DC input for connection to an external RPS, which is an external DC power supply that UniFi offer, the Enterprise Fortress Gateway has 2 dedicated AC power supplies that are hot swappable. And this is again due to the market that this is aimed at, where these are going to be installed in large comms rooms that potentially have things like dual power feeds, where you might have redundant power feeds into a rack. Having 2 power supplies built into each device makes it really easy to connect these to 2 different power feeds at the same time and have full redundant power without needing any separate external power supplies. And these power supplies are also hot swappable, making them dead easy to swap out in the field. You can easily buy a replacement power supply from Ubiquiti and swap it in. You don't need to return the device and actually get power supplies replaced or replace the device if it fails. These are completely hot swappable. So, yep, that's the power supply there. And for those wondering, these are 150 watt, 12 volt power supplies. And that's them there. The other thing you get with these power supplies is a cable retention mechanism. And it comes in the box in these 2 parts. Took me a little second to figure out how this all works. But on each power supply you'll notice that under the connector there's a little hole. Initially I thought that was like an indicator or an LED, but that's actually next to it. It's literally just a hole. So what you do is you've got this little zip tie piece here that pushes into that hole, like that. And then you have this little retention clip. So what you can do is you can plug your power cable into the power supply, slide this onto there, like that. That's then a zip tie, so that'll slide down. You can then put that into the back of the power supply, click that into place, so that'll secure it in place, put your power cable through this hole, and then tighten this down and tighten it all up. And what that then allows you to do is secure your IEC connector into the back of the power supply, which is really, really useful. I can't tell you the amount of times I've been working in a rack and there's been a device there that's not had a cable retention mechanism like this, and you're moving a bunch of cables around, trying to find the right cable, trying to get something untangled, and then you hear the dreaded little arcing noise of an IEC connector that's worked a bit loose, and you've ended up rebooting a switch or rebooting some sort of device just due to a cable coming loose. With this, you can easily secure those cables in place so it doesn't come loose. And whereas the UDM Pro Max does also have that, that only works with a special power cable that it comes with. Whereas this should work with really any standard IEC power cable, which means that if you're, say, using IEC to IEC cables in a rack, say to connect a PDU, you can still use this to secure those cables in place, which is really, really good. So before we power this up, let's talk specs. Because it's all well and good having really good network I/O, 25 gig Ethernet, all that sort of stuff, but that's all useless if the processor in this can't keep up with that amount of network traffic. But with the EFG, that's definitely not a problem. So in terms of specs, if we were to compare this to the UDM Pro Max, which would be the next sort of UniFi console in the range below this one, the UDM Pro Max has a quad-core Annapurna Labs CPU and 8 gigs of RAM. On the other hand, the Enterprise Fortress Gateway has an 18-core Cavium CPU. I think Marvel bought Cavium out, so it's Marvel now, even though this OS still reports Cavium, but an 18-core CPU and 16 gigs of RAM. So it just has an absolute ton more processing power. On top of that, it also has 128 gigs of SSD storage, so whereas you don't have hard drive bays or anything like that, it still has that 128 gig SSD, which can be used for things like log storage. But yeah, that CPU is an absolute powerhouse. It's a really, really high-end powerful CPU that should be absolutely brilliant for 25 gig Ethernet. So then if we take a look at the performance that translates into, Ubiquiti rate this as having 12.5 gigabit of IDS and IPS throughput. In comparison, the UDM Pro Max has 5 gigabits of IDS and IPS throughput, and the regular UDM Pro has 3.5 gigabit of throughput. And then later on we'll take a look at my actual performance benchmarks I did of this, and that figure they're giving is very accurate. This can definitely do 12.5 gigabit of IDS and IPS throughput. So what this means is that even if you don't really need 25 gigabit of throughput, if on the other hand you've say got a 10 gig WAN connection and you want a UniFi console, but you want to have IDS and IPS enabled, this device would allow you to easily get a full 10 gigabit of IDS and IPS throughput, whereas any of the other UniFi Dream machines wouldn't be able to get that total throughput. So even if you're not necessarily needing 25 gig, if you're wanting 10 gig, this device would be ideal for you. Okay, so I've now set it all up, so let's test it out. So what I've done here is I've built this little test setup, so I've got this little test rack here, and what we have is the Enterprise Fortress Gateway here. It's connected to a WAN connection over this cable here. We've then got this switch, which is a UniFi Switch Pro Max 24 port. That's plugged into the Enterprise Fortress Gateway using an SFP plus DAC cable, so that's plugged in there. And then just to give us another device to test with, just have a couple of devices adopted into the UniFi controller, we've got this UniFi U7 Pro Max access point here. That's also connected down here over this cable and into the switch. So that's the test setup. So let's fire this up and take a look at it working. Cool, so that's it all booting up, so I'll just let this all start up and we'll come back when it's ready. Okay, so everything's now started up and ready to go over here. So what I've now got is I've got my laptop over here, so I'll take my laptop, I'm going to plug it into the switch with this cable here, so that's the laptop now plugged in there, and then I'll jump over onto screen recording and take a look at the software side of things. Okay, so here we are in the web interface. Now, as you can see if you look at this straight away, it looks very standard, and that's because really in terms of the software side of things, this isn't really that different to a traditional UniFi Dream machine. If you look in here, we see we have the general console settings page, and as you can see, you have the Fortress Gateway here. You can set up shadow mode over here if you do have two and you want to run them in shadow mode configuration. We'll take a look at that later. And then down here, we have the network application. But because this isn't a Dream machine running Protect and Access and all those other applications, you don't have a big list of applications here, you've just got network. So we'll go into UniFi Network here. As you can see, you've again got a fairly standard UniFi Network application. So I'm not going to go into too much detail on this because it's basically the sort of same thing you're going to see on all different other UniFi controllers, and there's a million other videos on that. But there's one new feature that's exclusive to the EFG that we'll take a look at now. So if you look down here, you see you've got all the standard configuration. But if we go into settings and then security, there's this new option here called Next AI. And this is a sort of AI SSL inspection system. So with this set up, it will allow the EFG to inspect SSL network traffic and do things such as log information and block things such as websites, search terms, or specific file types. And when compared to other solutions such as IP blocking or DNS blocking, this is just a bit more robust, it's a bit harder to bypass, and it's a bit more flexible and customizable as to what you can actually block and filter. Now, of course, there's a couple of things to bear in mind with this. As you can see here, it intercepts encrypted traffic. So you're going to think, well, how does that work? Well, the way this works is it's an SSL inspection proxy, and therefore you'll need to install a different root certificate on any client devices that are being inspected by this. So this lends itself generally to corporate environments where you've got a bunch of machines that you're centrally managing, and it's not the sort of thing you're going to be using on sort of public networks where people are going to be using their own phones and devices, because those would throw SSL errors if this was enabled. Instead, you're going to be using this on devices that you centrally manage and can install a root certificate on. And of course, you also really need to think about the privacy of using a feature like this. This feature can be extremely useful in, say, educational institutions, schools, places like that, where you want to really be able to monitor and restrict what people are able to access. However, it's not the sort of thing you're going to want to use in, say, a large business handling very sensitive information or a home environment, and you really need to be very mindful of getting consent from the users to make them very clearly aware that this inspection is going on. But for those sorts of educational establishments, this could be a really useful feature. So we'll take a look at the configuration here. So you can either, like with the IDS and IPS, you can set it simple, which gives you very basic configuration, or advanced, where you can set much more kind of advanced rules and inspection profiles and things like that. And when you first set this up, there's a simple wizard, and that takes you through the process setting it up, and it gives you a root certificate to download and install onto the client devices, which I've already done here. So on my laptop here, I've already installed the root certificate that was generated by the EFG. So I've already got a configuration set up here from when I tested this previously, so we'll run through it quickly. So here we have what to inspect. You can either say you want to inspect all networks and traffic types or specific ones. And the likelihood is you're probably going to want to pick a specific here. Because say for example, you've got a business or an educational institution, sure, you might want to inspect traffic from all the student machines, but if you have any sort of public Wi-Fi or anything like that, you're not going to want to inspect that because you'll have all sorts of SSL errors and privacy concerns. So with this, you can pick specific and target specific networks. So on mine, it's just set to all networks just because it's a test setup. But if I was doing this in production, if you say I had a network for student workstations, you'd inspect that. But if you had staff workstations or the finance department or public Wi-Fi, you wouldn't inspect those. You can also target specific traffic types. So you can say if you want to target just web browsing, or if you want to target email and, well, just email protocols there. I'm just targeting everything, but I've only really tested it with web browsing. You can pick specific domains. So you can either only inspect specific domains, or you can inspect all domains. So you can either pick specific, at which point you can then add in domains that you want to inspect, or you can pick all and then exclude certain domains from your filtering. Next up down here, you can set actions. And this is where you can set different things that you want to block or not block. So for example, I've created a search for blocking searching for dogs. Don't know why I would want to not search for dogs. I would love to search for dogs, but just as a test, I've blocked the word, some various search queries. So I've blocked queries for dog, dogs, or golden retriever. So if you search for any of those, it will block that. And it blocks that against basically any search engine I've tried. I'm sure there's some out there that won't work with, but generally speaking, for Google, DuckDuckGo, Bing, all the major search engines, this will allow you to filter those searches. So now let's test it out. So first of all, we open up a new tab and do a search. First of all, let's try and search for cat. Search for cat, it works fine. But instead we want to search for dog, it blocks it. Same would work for other search engines, so try bing.com, go into Bing, go on Bing, search for dog, and it blocks it. So that works really well, and it allows you to quite easily block different search terms. Now personally, I'd like to see this expanded to have the ability to block categories of search terms, rather than just having to hard code different search terms, but as of right now, you can type in a list of different search terms, and it'll block them. And it also has some level of handling sort of simple misspellings apparently, so that's quite good to have as well. In terms of other filtering rules I've set up, I've got another one here for blocking streaming websites. So if I say go to netflix.com, again, that website's blocked. And then the final rule I've set up is to block downloads of executable files, which is one that I really like the idea of for those educational establishments where you don't want people that probably don't really know what they're doing downloading random executables and running them on your machines. So let's test that out. So for example, just try and download something safe, may as well. But let's go to just, I don't know, firefox.com and try and download Firefox. So we can go to the website, that works absolutely fine. But if I then try and download the file, wait a second for it to actually try and download the executable, and there we go, it's blocked it, and it says it's blocked Firefox installer.exe. So with that, I can easily completely block people from downloading executable files, which could be really desirable in some situations. On top of that, there's also the ability just to block websites in general. So these are ones with insecure certificates, untrusted certificates, or websites from a list that are classed as high risk, medium risk, or invalid domains. So I've enabled medium risk here, and this is websites that are potentially just regarded as medium risk by Ubiquiti. And these will automatically update different definitions, so the different categories of websites you can block will automatically update, as will things such as the medium and high risk websites. So one website I found that was a medium risk website was mediafire.com. It does make sense, it's a sort of file download website that often holds a lot of random files, some which can definitely be malware. So we try and go to Mediafire with medium risk websites blocked, mediafire.com, go to that, and it's blocked it because it's classed as a medium risk website. Of course, if you actually had a requirement to access this website, but you still wanted medium risk websites to be blocked, you can easily come into here and add an exception for that website. So it's dead easy to add exceptions, but you can still block websites that would be regarded as risky. So let's look at the actual controls here. On top of that, you actually get some sort of monitoring as well. So you come to the Insights tab here, and on here you're going to get the standard insights that you get with a normal UniFi console. So you get sort of the overall protocols and things like that. And you've got the SSL and TLS section, which normally that's as far as you can go. But if you've got the SSL inspection enabled on the Enterprise Fortress Gateway, you can go to this new inspection tab up here, and this gives you a lot more detail. So on this, you can see all the different web pages being visited. So you can see the actual URLs. You can see, so we go to say queries, you can see all the different search queries you can do. You can look at what's allowed or what's blocked. So this is all the domains that are actually allowed, that I've been allowed to connect to. So it's really, really useful, and it's really, really flexible just to be able to see this, see what websites are being visited, see what search terms are being used. Potentially you can then use this to kind of guide anything you might want to block. So it is a really, really neat feature. Of course, it's very important to bear in mind the privacy concerns of inspecting and decrypting SSL traffic. You do not want to be doing this in a situation where you're dealing with highly sensitive information, but in those educational settings, places where you've got children using the network, the advanced filtering that this offers may still be worth it over the privacy concerns of decrypting SSL. But obviously, if you're using this in any sort of situation, you need to be very aware of what you're doing, and obviously make sure that anyone that's using a machine that is being inspected in this way is aware of that inspection going on. But yeah, that's the new next AI inspection feature, and it'll be really interesting to see what features they add to this over time. So now let's talk performance tests. So here's the performance testing setup. So what I've done is I've used my 25 gigabit capable traffic generator that I've made a previous video on to test the performance of the Enterprise Fortress Gateway using iPerf. So if you're interested in seeing more about this performance testing setup, I've made a dedicated video on it. And if you've seen that video previously and wondered why I was building a 25 gigabit capable firewall testing setup, it was, well, because of this. I obviously couldn't mention it at the time, but I needed to test this out. So what we have here is we have this machine here that will be running iPerf, and we have it connected to the Enterprise Fortress Gateway over two SFP28 25 gigabit DAC cables. So port 0 on the traffic generator is connected to the WAN port on the Enterprise Fortress Gateway, and port 1 on the traffic generator is connected to the LAN port on the Fortress Gateway. And the way I have this set up is I can run the iPerf server on port 0, the iPerf client on port 1, and test through the Fortress Gateway, essentially as if I'm testing downloads and uploads to and from the internet. So we have the iPerf client set up ready to go here. So we run that, you can see we're running a performance test through the Fortress Gateway, and it's measuring the performance. Now I've already done all performance tests already, so I've tested this with upload and download with IDS and IPS enabled and disabled, and I've also compared it to UniFi Dream Machine Pro Max. So what I'll do is I'm going to jump in and take a look at the performance tests. So with IDS and IPS disabled, I was able to download at 19.8 gigabits a second and upload at 20.3 gigabits a second. So with that, you're almost getting wire speed. You've got to factor in that these tests were done with iPerf, which only tests at a lower layer. It tests more the actual useful data throughput that you'll get. It's not the amount of data actually traversing the network interface, because it doesn't factor in all the overheads of the Ethernet framing and the TCP and all that sort of stuff. So then I enabled the IDS and IPS. So I just set it onto standard profile, just kind of default configuration, but I enabled it. And with that enabled, I got a download speed of 15.5 gigabits a second and an upload speed of 18.5 gigabits a second, which is ridiculous. Ubiquiti rate this for 12.5 gigabits of IDS and IPS throughput, so I was actually getting more than that. Of course, I wouldn't necessarily completely trust my performance figures. If they say 12.5 gig, don't buy this if you need more than 12.5 gig. Of course, with this, it was a benchmarking sort of test setup. There wasn't really any other load on this, and it had a very simple, almost default configuration. But the fact I was able to easily beat the 12.5 gigabit performance figures shows that their performance figures are definitely very achievable in the real world. And as I mentioned earlier, being able to easily get beyond 10 gigabits of IDS and IPS throughput makes this device absolutely brilliant for people with 10 gig WAN connections that want to use a UniFi gateway with IDS and IPS enabled, because up until now, they simply haven't had a UniFi gateway that can handle 10 gigabit of IDS and IPS throughput. For comparison, I also set up a UniFi Dream Machine Pro Max, again, the next level down in the range from this. So I set that up and did the exact same tests. So the UDM Pro Max with IDS and IPS disabled, once again got 9.21 gigabits a second down and 9.44 gigabits a second up. So in the same way that this maxes out the wire speed with IDS and IPS enabled, the Dream Machine Pro Max does the same thing. Of course, it's lower than this, but equally the Dream Machine Pro Max only has 10 gig Ethernet, it doesn't have 25 gig Ethernet. So the UDM Pro Max with IDS and IPS enabled can basically get wire speed. But then I enabled IDS and IPS on the Dream Machine Pro Max. And with that, the download speed was 5.35 gigabits a second, and the upload speed was 7.8 gigabits a second, which is obviously significantly lower than 10 gigabits a second. So when you compare the IDS and IPS throughput of the Dream Machine Pro Max, which is already a very powerful gateway, to the new Enterprise Fortress Gateway, it really shows how powerful this thing is. The power and performance of this is absolutely brilliant. So as one final test, let's take a look at the automatic shadow mode high availability feature of the Enterprise Fortress Gateway. Now I've already made a dedicated video on automatic shadow mode, so I won't be going into a huge amount of detail in this video, but what I thought we'll do is we'll set it up, take a look at the setup process, and then quickly test it out. Because what this allows you to do is to have two Enterprise Fortress Gateways configured in a high availability pair, so if either goes down, your network stays up. So for this, we've got the original Enterprise Fortress Gateway that we used before set up here, that's already set up and working. And I've introduced this new Enterprise Fortress Gateway here that's sitting in a factory reset state. So it's a completely factory reset. It says plug-in cable to plug in a WAN connection. If I was to plug this straight into a WAN connection, it would go through the initial setup process. This is a completely factory stock, factory reset Enterprise Fortress Gateway. So to set up automatic shadow mode, the process is basically the same as on a UniFi Dream Machine. You plug the WAN connection of the secondary gateway into a LAN port of the primary. The only difference is on the Fortress Gateway, you've got a different set of ports, so you kind of need to connect up a little bit differently. Whereas on a Dream Machine, you usually just use a copper Cat5 or Cat6 cable and plug the WAN ports into the LAN port. It's a little bit different here because you've only got two copper LAN ports, and you'll need these at a later point in the setup. So instead I'm going to use this SFP plus DAC cable instead. It does the exact same job, just means I can use the ports that are available. So as I mentioned, we're going to plug the WAN connection of the secondary gateway into a LAN port of the primary. So we plug that in there, and then take a look over at the web interface. We'll just let this sit for a couple of seconds, and once it's all detected and all set up, you get a little notification saying it's detected the shadow gateway and do I want to set it up. So let's wait a little second. Okay, so you can see here it's now detected that, so we can now press click to set up, and it'll now take us through the setup process. So the first thing you'll notice is it'll say syncing, and it'll sit for a few seconds and then say in sync. What that means is we've set up shadow mode, but it's not automatic shadow mode. So what will happen now is the primary gateway will constantly synchronize its configuration with the secondary. But if the primary were to go down, to switch over to the secondary, we need to come in here and swap a few cables around. That may be fine for your setup, but we can go a step further with automatic shadow mode. So to do that, we press enable automatic failover, and it'll bring up a nice easy to use wizard that takes you through the setup process. So the first thing it'll tell you to do is connect port 2 on both gateways together. And this is why I didn't want to use an RJ45 cable to do this initial setup stage, because I needed these two ports free. So we use a little patch lead here, and we'll connect port 2 on the primary gateway into port 2 on the secondary gateway, just like that. Once that's connected, we can come over here and press verify, and we'll get a little tick that says that we're connected. We can then press next, and it'll now say it's setting up a high availability cluster. This will take a few minutes, and this is it setting the whole system up, So once this is done, we'll come back. And we're back. So it now says it's created a high availability cluster, so we can press next. And what we now need to do is adjust the WAN connections. But because as you can see right now, the WAN connection on the secondary gateway is connected to the primary. So of course, if the primary went down, this would lose its WAN connection. That's not going to work. So we need to take out that cable that we put in previously, so we'll disconnect that there. Take that out of the way. What we now need to do is connect a second WAN connection into the secondary gateway. So I've already got a second one here ready to connect up, and both these WAN connections go off camera and plug into a switch. So that's kind of what you need to do in your setup here. You need to have both your WAN connections go through some sort of switch. Of course, if you're building a high availability setup, you probably also want to have redundant switching there, do something at that point. You kind of need to design that into your own setup, but essentially what you need to do is have the same WAN connection connected into both Enterprise Fortress gateways. If you had multiple WAN connections, what you would do is you'd have your primary WAN connection would connect to both gateways, and your secondary WAN connection would also connect to both gateways. Because high availability mode here is designed for a gateway failure, not the failure of a WAN connection. So you connect both WAN connections into both gateways through switches. So that's what you do there. But what we've now done is rearrange those. So we've connected the WAN connection into both Fortress gateways, taking out the interlink that was between the two. So all we have is this link on port 2. Press next. And what we now need to do is connect the secondary gateway into the switch. So we've got our single switch here connected into the primary gateway. So we need to introduce another cable here, plug that into there, and plug the secondary gateway into the switch. Now, of course, if you've got some sort of additional switch, you've got more than a single switch here, which you probably would have if you've got such a powerful gateway, you would kind of need to design this in. You'd potentially uplink to some sort of aggregation switch, potentially have multiple aggregation switches in a high availability setup there. You kind of need to design in the redundancy at this point. But for the simple setup here, what we have is both Fortress gateways are plugged into the switch. So we can press finish here, and now we have automatic shadow mode set up. Okay, so let's test this out. So what we have here is we have my laptop connected into the network, and I'm just constantly pinging out to the internet. So there's a constant ping that's running out to the internet. And as you can see right now, we're still running through the primary gateway. So what I'm going to do now is pull the power to the primary gateway, and what you'll see is we might lose maybe 1 or 2 pings, not many at all, and then we'll straight away switch over, and it'll automatically switch over and start forwarding by the secondary gateway. So let's test it out. So what we'll do is we'll pull the power to the primary gateway up here, like that. It's killed. See, the pings have stopped. Give it a couple of seconds, request timed out. And then straight away, we're back. So as you can see, the internet connection is back online. Lost maybe downtime for maybe a couple of seconds, if that. And straight away, we're now being handled by the secondary gateway. So you can see the primary is now off. It's completely dead, unplugged, no power to it. And the secondary gateway is working. So as you can see on the screen on the front of it, it says network online restoring UniFi. So what that means is it's straight away switched over the forwarding and networking and UniFi application and the networking application. So all the firewalling and all that stuff is switched over immediately. And then in the background, it's reloading all the UniFi services, bringing up the UniFi controller, the web interface, all that sort of stuff. So it straight away takes over the network. Your network comes straight back up, and then there's a few minutes where all the UniFi applications start up. And once all the UniFi applications are up, we can go in and manage the network as if nothing had happened really. And then once the primary gateway comes back, it'll switch back over to make the old primary gateway the primary again, and everything will go back to exactly how it was before, with the shadow mode gateway sitting as a shadow gateway waiting to take over. And as you can see on here, the screen now says failover activated, it's now completely failed over, press dismiss, and now we're completely back up and running on the secondary gateway. So yeah, there you go. That's automatic shadow mode on the brand new UniFi Enterprise Fortress Gateway. So there you go. That was a look at the brand new UniFi Enterprise Fortress Gateway. And it's a really cool device. I'm really glad I was able to take a look at it. Obviously, this is not the sort of thing you'd use in a small business or a home environment, but if you've got a large-scale UniFi deployment where you need a lot of processing power, especially when it comes to IDS and IPS throughput, this device is absolutely brilliant. And it's great to finally have a UniFi gateway device that can easily break the 10 gigabit IDS and IPS throughput barrier. In fact, I'm thinking back to the days when I first started looking at UniFi, back in the day of the UniFi security gateways, and I remember the sort of non-rack mount version of that couldn't even break 100 meg of IDS and IPS throughput. So the fact that you now have a device that can easily surpass 10 gigabit or even 12 gigabit of IDS and IPS throughput is absolutely brilliant. So yeah, that was a quick overview of the brand new UniFi Enterprise Fortress Gateway. So yeah, hope you found that interesting. But all that's left to say now is thank you very much for watching.